like if someone makes a mistake and it doesn't compile, but it's the best they can do, and then they fix it and resubmit, you can give them credit for turning it in late and working, as opposed to turning it on time and not, which might be better for them.
I think people have been procrastinating sometimes, so. All right, well, let's go ahead and get started. I finished the answer of the practice exam. I posted it online already. If you look up today's date and cisp310, you should be able to find it. Let me make sure.
You didn't just upload the code?
So will there be 2 videos with today's date?
Yeah, so if you go to YouTube and look up today's date and cisp310, you should find it. Sorry? Hello? Okay. Yes. What was the question?
Will there be 2 videos for today's date?
Yes, there will be two videos of today's date, because one is the answer to the test and the other one will be for the lecture. And let me make sure that today's lecture is getting recorded. And it is. And it's being a little bit slow. There we go. So you can see. Okay, this is the answer to the practice test. It is 2011-0407 cisp310 X2 for exam 2, and then ARC. So you will find 2 video clips from today. One is the lecture, and the other one with the X2 is for exam 2, or the practice question of exam 2. And when I was doing it, I was actually doing it pretty much from scratch. Even though I made the question myself, I have completely forgotten what I did to mess up the program. So I had to start from scratch, and so you will definitely see that it's not staged. It's definitely not scripted or staged. I just sat down and here's the recording. This is how I'm gonna do it. So, and even so, it took what? Let's see how long.
30 minutes.
Yeah, 30 minutes or something like that. 32 minutes and 15 seconds. I hope the resolution is sufficient. I did not actually bump up the font size, all the way up. So, I think this is still legible. Okay, I think it's still legible. I went through the whole process too. I used GDB and debug subroutine by subroutine. So hopefully the approach is also something that you guys can pay attention to, and not just really the source code after everything is fixed, but also the procedure how I go about doing it. Are there any questions about this? No questions? Okay. I think that's the highest. Oh no, you can actually bump it up to 480.
Doesn't look any clearer.
Still loading.
Yeah, I think that's not bad. I mean, you can definitely read it. Yep. You can do a screen capture and then do a OCR, so you can get the actual source code out of it.
It would be faster to transcribe it.
No. Well, but the whole point is, I actually did it step by step. So, I think it's the process that is more important, because you're guaranteed that you won't see exactly the same program or even close to this program. So your assignment, your question is not going to be about LCD or LCM or GCF, or something like that. It's just that the complexity will be about the same. Okay. So, are there any questions about the practice test? Now that we know where to find it. So now I'm not going to talk about this in the class, because I know some people may not have a chance to work on this yet. And you have until next Thursday to work on it. Next Thursday is, when our exam 2 is, because next Tuesday I cannot be here. I have to stay home and watch the kids. So I will probably produce another YouTube, thing for next Tuesday. So there will be some content that you guys can watch, but you don't have to be here, obviously. You can watch it at home or some other place. So there will be some content, just to make sure that we can cover all the material that we have to cover. Any questions? Yep.
Is there a new assignment due yet?
There's no assignment, as per the request of several students, because they think they need the time to study. So that means I can make the questions a little bit. So I can assume people are studying harder than last time. I'll stop there. Yeah.
Will you bring printed copies of the code so we can have something
Of which code?
on the test next Thursday?
Oh, the test. Okay. Can you send a reminder on Wednesday? Yeah, just to make sure that I remember to bring hard copy, because that's usually not what I do.
It just makes it easier.
Okay, I can do that. Not a problem. Okay, any other questions? No questions? Okay, here's the row sheet of today. And do you guys want me to do the homework assignment, subroutines 1? Or is that kind of like, you guys want me to do it? Okay.
I'd like to see your version of it.
My version, but you guys always do. You never like my version, though. I mean, you just want to look at my version so you can criticize it. So,
How do you get better if not through crit analysis?
all right. So everything starts with this zip file. This is what I'm going to do. Is to actually do the homework assignment, step by step, so that you guys can see, how to approach the programming assignment. A lot of times, I have seen people doing this in the lab, how, programs, were written, not only for this class, but also for other classes. I have seen people writing, 50, 60 lines of code without running it through, a debugger or even a compiler for that matter. Okay, that's usually not a very good idea because, I would not write that many lines of code without testing it first. Okay, I would write, at the most maybe 15, 20 lines at the most, and then I will stop and actually test the program, test, the subroutines or loop or whatever, I have written, and make sure that part is working before I add any more code. And that's because with any type of programming, if you write 20 lines of code, then you have 20 lines of possible bugs. Okay, and if you add more to it, then the number of possibility or the number of bugs you can introduce, is going to increase. And sometimes you can have interactive bugs. One bug can interact with another bug, and as a result, the symptom does not show up. Okay, one bug can cancel the symptom of another bug. So as a general rule, I don't write that many lines before I test my programs. Especially when you have to write several subroutines, I would definitely test the subroutines one by one first. Okay, so let's see if we can, use that approach, for this assignment. And okay, that's the wrong link. Where's the link to the file?
Very bottom.
Very bottom. Oh, there we go. Throw me a bone. Here's the bone. Did you guys find the bone helpful? I mean,
No.
It saved about 5 minutes of time.
It was helpful, but
It was still appreciated.
The make file is
The make
then it makes me back up again.
the make file was what?
Like it saved me time at the beginning, but then because like I was so happy, I copied the tar command again, and yeah.
Oh, I should have made the tar file also a target of the make file. Then you can just say make tar, then it will create a tar file or something like that.
Oh, that's a great idea.
Yeah, but I don't think it's
Make
necessary.
answer.
You guys should be able to do
All we
that
have to
now.
do is go to a previous assignment, copy the tar command, and change the name of both files, and it does the same.
Pretty much.
You're so happy that you just want to copy that tar command.
Well, that's the thing about consistency. If it's consistent, then you can use the same approach all the time. All right, so here we start with the 4 files that are given to you. The make file is something that you don't really have to deal with because it should work, from the get-go. And one thing you can do is just to do a make first and make sure that everything works out. So I just go into GDB, print base. And in here, you can put a breakpoint in at the beginning of a subroutine. In other words, I can put a breakpoint in subroutine F. F has nothing. F only has a single return statement, but I can still run the program and see if it works. So run the program, and it stops now on line 3 of F.S. Okay, so it can stop at a file that is different from the original file. The original file is the file that contains the underscore start symbol, because that's the entry point of the entire program. Okay, if you look up help break, it will also show you what you can do with the break command. And there are a lot of fancy stuff you can do, but one thing in particular is well, it has to do with the location, because the location can look for a particular file too. Does it say anything here? If a function is specified, break at the beginning of that code for that function, which is helpful because you can basically stop execution when you are at the very first instruction of a subroutine. So that can be helpful. I'm surprised that it doesn't show how to stop, inside the program, or to put a breakpoint in a particular file.
File name : line number.
Yeah, but where did it say it? Maybe it's under list. Oh, it's under list, because list can do it. List can, specify the file name and then the line number, and then break uses the same standard as list. Okay, so anyway, that's just a tool thing. You can deal with that later. Okay, so let's go back to my homework assignment and find out what I'm supposed to do. Yes, I made a homework assignment and I have no idea what I'm supposed to do here.
Are you even sure it's possible?
Pretty sure it's possible. Everything is possible. All right. So we have to implement two subroutines. The first one is put char. I would test, put char first. Okay, I would, approach put char first, just because it is called by f, and also it is a little bit simpler than the other subroutine. And then the other thing is, we talked about put char in the class already. Okay, when we went through the spreadsheet, step by step, it is almost done entirely, except I did not spell out which register to use and how to adjust the value of that register to compute the address of the parameter. Okay, I stopped short, just not tell you, which register and what displacement. So that's pretty close to the solution already, and I think I will start with that. Okay, print base dot s. Okay, so we have this code. No, we want put char, don't we? Okay, so for put char, you can basically copy and paste, for the most part. But if I were to start from scratch to write the entire thing again, this is how I would do that. I would say, EBP gets 0. Do you guys still remember why I would say that? Because EBP as the frame pointer always points to the location where we store the saved value of EBP. So that's why it is the old value of EBP, or old EBP in short. The next item up is the return address. The return address is basically quote unquote pushed by the call instruction. It's not done by an explicit push instruction, but it is nonetheless the same thing. We are pushing 4 bytes on the stack that is the return address. The parameter is right next to it. So ch is return address plus 4. Okay? And if we look at the subroutine here, we don't need any local variables. So those are all the symbols that we need in order to access items on the call frame. When we get into the subroutine, there are several things that we always do. One thing is we always save the frame pointer. Now, if you save the frame pointer, that means you also have to restore the frame pointer later on. And we also want to take a snapshot of the stack pointer so that we have the frame pointer pointing to that particular place that we wanted to point to. At the end of the subroutine, we reverse these operations so that we can make sure that the stack pointer is at the right place before we pop EBP and then return. Are we still doing okay at this point? Now you can see that when I write a program, a lot of times I don't write it sequentially. I don't start with the first line and then just keep going. I usually kind of go from the beginning and then the end, because I want to make sure the structure of the program is correct before I fill in the content within the structure. Okay. Now with this particular program, if you have seen the other code, the ones in the notes, you already know it's going to trash EAX all the way up to EDX. And since I don't want the caller to have to deal with this, I'm going to save all the registers and then restore all the registers later. So this part is the same as before. We save EAX, EBX, and ECX, and then EDX. And when you pop these, or when you restore the registers, you have to do it in the opposite order. So that means, when you pop, you have to pop EDX first, and then ECX, EBX, and then EAX, because the stack is organized in the last in, first out fashion. Is that part okay so far? Yep.
Why do you do the for commands as opposed to push flags?
Instead of
Push flags?
the flag register is usually not assumed to be unchanged by the subroutine. So if the caller has to maintain the flag register, the caller can always do a push F and then a pop F.
Push registers.
Oh, you mean push A and pop A?
Yeah.
You could do that, but that's very expensive because it could be pushing and popping a lot of the registers that you don't even need to assume that they are safe. But it's not wrong. It's just kind of wasteful, kind of expensive operations to do that. All right. So once we have all this code to save and restore the registers, to set up the frame pointer and whatnot, it's time to actually place the call. The call, if you copy from the code that I have already mentioned, it's 4 into EAX because we want system surface number 4 to write something to a file. It is 1 into EBX because it is the standard out file handle. And let me deal with the easy one first. EDX specifies how many bytes we want to write, and we only want to write at the most 1 byte. Okay, so here's ECX, which is the address of the byte that we want to output to the file. How do we calculate that? Well, we used to use a stack pointer, but the whole point of using the frame pointer is we don't have to deal with all the calculations because of the push and the pops. Particularly, let me use the line numbers here. I don't have to deal with the displacement of the stack pointer because of line 8 to line 11. These pushes and pops have nothing to do with the parameter at all. Okay, so I don't want to have to deal with that. So that's why I would use the frame pointer instead, EBP. I will make a copy of EBP into ECX, so they now point to exactly the same place, which is the saved value of EBP before it became my own frame pointer. But that's not what I want to put into ECX because what I want is 8 bytes away from where EBP points to. So that means I just need to add, and I can just say 8. That's fine. But since I have a symbol already defined for the parameter, I can say $CH to ECX, and that completes the calculation of the address of CH. Are we doing okay so far? These 2 lines are the only 2 lines that are different from the code that we have talked about so far. Okay, the spreadsheet. Remember the spreadsheet that we traced on last Thursday? I think it was last Thursday. These are the only 2 lines that have to be changed in order to make it to work. And once this is all done, we can do the software interrupt, and we're ready to go. Now someone's going to complain and say, attack, you just typed 26 lines without testing anything. Well, that's not entirely true because we actually tested everything up to, but excluding these 2 lines. That's the only 2 lines that I changed from what we talked about last Thursday. So technically speaking, I did not write 26 lines without testing it. I changed 2 lines without testing it. Okay, so are we ready to test just this function first? Okay, so let's go ahead and test this function. Yep.
What if I put and move $1 into EDX after the add jar into ECX?
You can do that. That's independent. I mean, these 3 instructions, from line 13 to line 15, they do not depend on anything else. As long as they're done after the push and before int $0x80, you're fine. The only restriction is line 16 and line 17. They have to follow in that particular order because they're both using ECX for the calculation. Okay, are we ready to go? Well, let's give this a try first. Okay, so we want to try out this particular subroutine, make sure it works before we go to the other subroutine. And to do that, we go to printbase.s. Even though I said don't change it, we can go ahead and just insert a little bit of code. And what I usually do is I would just at least write down some comments to remind myself this is not a part of the homework assignment, and I have to delete this part before I turn it in. So I will just say test code or start test code. Whatever you write, you just have to remember what it is. And test code. So this way I know where I'm supposed to delete what code in the in print base.s I'm supposed to delete. I can print. Let's just print 3 characters TAK. Okay, so that's what I would do. So we can say push L $T call put char. There we go. And if you prefer to have a line feed character at the very end, you can just push a 10 here. And of course, it will work, but I'm wasting space on the stack because I'm not undoing everything. So technically speaking, it is better if I just deallocate the 4 bytes after the call, because after the call, those 4 bytes have no use anymore, and I should deallocate those 4 bytes from the stack. Question? Yep. Okay. I will probably have to put a breakpoint at call here because I want it to stop at that point. All right, so let's make and GDB print base, put a breakpoint at what was it again? Call here, and just run the program, and the program just printed out TAK and the line feed character, and it is stopped at the right place without crashing. So the program is doing okay so far. Okay. Are there any questions at this point? Yep. Oh, I thought you had a question. Nope. Okay. Yep. Go ahead. $1.10 is the line feed character, which is a Control J. That's the line feed character. So print base is done. Well, as far as I know, as far as I can test, it is done. Now it is time to move on to, I think, the function f. And let's take a look at the code that I'm supposed to implement for function f. Now this is also a good idea, is just to copy and paste the code so that you have a reference to the original C code when you write the code in assembly. So this is what I'll do, is to copy and paste it in VI. It will work. It's just going to look a little bit ugly.
It always looks ugly.
No, it'll work because I cannot paste the indentation in HTML. So that's so even with auto indentation, it doesn't do anything.
So when are you going to commit your code to your repository so that you can go back if you make a mistake?
Yep.
Are there block comments in assembly?
Are they what?
Can you do a block comment in assembly?
No, you cannot. You cannot do block comments in assembly, so you have to start each line of comment using a pound sign. Okay, so now we have the C code pasted in. I just have to comment out the entire thing. So from line 3 to line 14, substitute the beginning of each line with pound and the space. There we go. So now it's all commented out.
You lied to us. You do have a way to block comment.
Sorry?
You lied to us. You do have a way to block comment. It's just with Vim and not assembly.
Yeah. There's actually a way to do it. Once you use once you use a preprocessor, you can use pound if 0 and pound end if to kind of emulate the effect of a block comment. But since we are not using the preprocessor yet, we can it's too early to mention that trick. Okay, so it's time to just take a look at this one here, and I'll do exactly the same thing. The first thing is to find out all the displacements to all the items that I need to access on the call frame. In the call frame, old EBP is 0, return address is old EBP plus 4, and then we have the first parameter called x, so x is return address plus 4, and then we have b, which is x plus 4. Are there any questions about these definitions of symbols? No questions? In other words, if you just look at how these symbols are defined, since old EBP is 0, return address is really just 4. Now, since return address is 4, X is nothing just more than, it's just 8, and B is nothing but 12. So those are the actual values of these particular symbols. Now, I like to refer to the symbols, because they are symbolic names, and I don't have to keep track of all the numbers. In case I want to add one more parameter, I don't have to recalculate everything and change all those numbers in the program, because I can just change the definition of the symbol itself. All right, so let's go ahead and write the program. I move this one over here. The first thing is, basically every time you use a subroutine, these days, from now on, you have to say, push EBP, and then move ESP to EBP. At the very end, you have to undo those two operations, and the way you undo it is just to do it in exactly the opposite order, like so. Any questions at this point? So I'm just defining the entry point and the exit point of the program at this point. I don't have any local variables, so there's nothing to do at this point. And I'm ready to compare the two parameters now. Now, in this case, using the structure that we have talked about, we want to go to the else case if x is not less than b. So that's what we are going to test for, is when x is not less than b, we want to branch to the else case. So since I already know what I want to do, might as well just put an else label here. So we'll say, I don't know, f else. Okay, f is the name of the subroutine, and else is here. Now, every time you have a conditional statement that has a then portion and also an else portion, the then portion will have to jump around the else portion. So you have to say, and if here, and at the end of the then portion, you have to do an unconditional branch to the end of the entire conditional statement. Are we doing okay so far? Does everybody understand why I have all these labels and the unconditional branch instruction? Yep.
Can you go down to line 25, I think it is now? Is that?
It's wrong.
Oh, it's the
backwards?
wrong
Should
order?
it be
Yep, it is.
EBP or-
Yeah, you're right. It is in the wrong order. There you go. Good job. Now, if I did it like that, then I actually did not actually undo the operation, and it would still be okay, because as long as the stack is balanced, it doesn't really do anything. So I would be burying a bug that can become a problem later on when I do have push and pops. So that's a very good point. I'm glad you brought it up. All right. So now that I have all the labels in place, now I can actually go and try to perform the comparison. Essentially, what I want to do is to say compare bx, and I want to branch to f else if and only if x is not less than b. So I can say if x is not below b, go to and if. Nope, else, sorry. Because we do have an else case in this case. So if x is not below b, I want to branch to f else. Yep.
B and X are just defined to be constant values. So that's always going to, jump. Or not.
No,
jump.
actually, in this case, it will have an assemble time error, because the way they are used here, they are direct operands, and direct operands are all memory operands. And now we have two memory operands on the same line, and that can never happen. So I'm doing this only to remind myself what needs to be compared and what is the order of the comparison. Okay? But since I already know this cannot happen, I have to move one of these into a register first, and then I can do a compare long. So I will move one of these, let's say B, into a register. Might as well just use EAX, and now I can use EAX in place of B, and then the other one is just X, using the base addressing mode, because EBP gives me the approximate location of where the parameter is. X as a symbol is the displacement from where EBP points to the actual parameter. Yep.
You always have to use EBP, the frame pointer, right? When you're putting something into it, it's like putting a variable into EBP, you always have to put the variable into EBP.
EBP is a frame pointer, and the parameter is a part of the frame. and I define the label X and also B as a displacement from where EPP points to the component on the frame that I want to access, and that's why this is the proper addressing mode to use.
So when you talk about the frame, you're just talking about everything between EVP and ESP?
When we talk about the frame, it typically consists of the parameters, the return address, the old EBP, and also all the local variables. So those are all a part of a call frame. In this case, we only have parameters, the return address, and the saved EBP. We don't have any local variables in this case. So are we doing okay with these instructions? How I implemented the conditional part of the conditional, the condition of the conditional statement? Is that doing okay so far? Okay. So the rest is actually not too hard, because this is a call to put char. I need to push a parameter on the stack in order to get this done. There are many ways to get this done. Okay, you can do everything in a register and then push the register. You can also do a trick like this. You can say push L, the ASCII code of 0, and then you can add L, the value of X. Oh, that won't work. Okay. Okay. This will work though. I only have to reverse it because I can only have up to one memory operand in the add L or any instruction. So this will work. All right. Let's see why this will work. Okay. Now I want to kind of use the obscure combination of instructions instead of the plain and simple and really obvious solutions, because I don't want someone to tell me and say but Tech, in the class you never teach us anything that is obscure, and in the exam how comes we have all these strange combination of instructions that will magically accomplish what we need to do. So here's one of the obscure combination of instructions. The first instruction is pushing the parameter on the stack, right? Because X, using the based addressing mode, with X as a displacement, that's basically our parameter X. Is that okay so far? And I'm pushing it on the stack. But Tech, isn't that going to cause some problems? Because you are using a component that is on the stack and you're pushing it on the stack itself. Doesn't that cause some kind of conflict and problems? Nope. It's because I'm using the frame pointer. The frame pointer is always pointing to exactly the same place. It has no relationship with the stack pointer, once it is initialized. So that's why we can do this without any problems. I can move the stack pointer, and the frame pointer will still point to exactly the same place. And then the second instruction on line 18, what are we doing here? The first operand is easy. Okay, the source operand is just the ASCII code of 0. Okay, if you don't like quote 0 quote, you can look up the ASCII table and just put in the number itself. But what am I adding it to?
Will both work with 0 or the ASCII code of 0 work, but you have to put it in quotes though, right?
If you use the number, which is the ASCII code of 0, then you don't need the quotes.
But if you just use the regular number, then you do need the quotes.
This is the ASCII code of 0.
Oh, 0 is okay. I thought that was like code.
This is quote 0 quote becomes the ASCII code of 0. So what am I adding it to? I'm adding it to not the stack pointer, but what the stack pointer is pointing to. What do you think the stack pointer is pointing to? What was the last item that I pushed on the stack?
For new X.
Yeah, exactly, the parameter X. So this is going to accomplish exactly what I need to accomplish. And once I have the parameter pushed, I can then call put char and basically remember to undo these 4 bytes later on by adding 4 to the stack pointer. Is that okay? I know the combination is not obvious, but that's the whole point. I want you guys to see alternative ways of doing this. Okay, not just how to put everything into a register, do all the calculations in a register, but also some of the more obscure ways of doing things, because it gets the same job done. I mean, it really does. Are we doing okay? All right. So now we go to the else case. The else case has to implement something a little bit different, because first of all we have to have a recursive call to function f. Okay, And when we perform this, when we perform the recursive call, we have to push b first, and then we have to push the quotient of x divided by b. Okay. Well, first thing first, we'll go ahead and push b first, and that pushes parameter b on the stack. Now we have to compute the quotient of x divided by b, and the div L instruction is already explained, so I will just go ahead and do that. You have to put 0 into edx first, because edx is the most significant 32 bits of the 64-bit dividend used by this particular instruction. And then you have to initialize the least significant 32 bits of the 64-bit dividend, which is going to be x. So you put x EBP into EAX. And then you have to specify the divisor. Divisor can be in any register. So we'll go ahead and put B EBP into, say, EBX here. And then we are ready to do the division instruction to divide it by EBX. Is that part okay? This takes care of the division. Yep.
Why not just do div L B EBP, since it works without it being in a register, and you don't need it in a register for anything else?
Well, let's just say that we don't know that you can use div L using a memory operand. So this is always safe. You can always do it with a register operand. Yep.
Div L EBX, that's dividing EBX by EAX. That will
EAX by
Oh, EAX by.
The dividend is EDX colon EAX, and then the divisor is EBX. The result, there are two results from this division. The quotient is in EAX, and then the remainder is in EDX. Okay? All right, so, and then we look at this instruction here, or the operation after this. Now I can be redundant, I can redo the calculation. Let's go ahead and do it in a redundant way first, and then I'll show you guys how to do it in a way that you don't have to do the division again. Okay, so we'll do it the long way first. Now that I'm done with the division, the quotient, which is what I need to call f again, is in EAX. So the next push instruction is just going to push EAX on the stack. Now I have both parameters pushed on the stack. I call f. When f returns, I have to compensate or undo the 8 bytes, deallocate the 8 bytes that I push on the stack, and that's the function call. Line 27 to line 34 implements the recursive call that is stated here. No? That's okay. All right. So now we are ready to do the second part. Now I'm just going to do the second part, kind of more redundantly this time, and then I can show you a trick so that you don't have to do it so redundantly. Basically, I'm going to set up everything the same way. So we will copy all these lines from line 28 to 31. Okay, 4 lines, and put it here. Now I need these 4 lines again because I forgot that I have this calculation already done. Okay, let's just say that I forgot that EDX already has the remainder from the previous divide instruction, and I just want to do another division in this case. But the calculation is the same. Whether you want to get the remainder or whether you want to get the quotient, you still have to set up the registers exactly the same way in order to finish the calculation. Except in this case, I don't really need to know what is the quotient. EAX is useless to me. This time it is EDX that is useful to me. So I would certainly push EDX on the stack, which is the remainder of the division, and then add the ASCII code of 0 to what I just pushed on the stack. This is basically the same trick as last time. And then I call put char and come back and clean up those 4 bytes that I pushed earlier on the stack, and that will accomplish the put char function call here. And then there's nothing else. You should be all done. And yes, this time I did write about 40 lines of code without checking. Now you can still kind of check stuff, by changing the test case so that you can test your subroutine to make sure that it works up to a certain point. But let's just be brave in this case and see if it works. Okay, GDB, print base, and run it.
Yep.
108.
Perfect.
We're doing 98 base 9.
Yep. So it does work.
89.
It does work because the 8 is telling me it has 8 ones, the 0 is telling me it has 0, 9, and the 1 is telling me it has 181, which is 9 squared. 81 plus 8 is 89. Right? Did I say it right?
Yeah.
Okay. Sometimes I don't. Is that doing okay so far? So we have to test it with different test cases too. So I would go back to the program, go back to print base. Sometimes I wish I actually made a mistake somewhere so I can show you how to find out where the bugs are.
You could try
But
making
wait,
them
I
on
have to
purpose.
grade your homework assignment, so I will have plenty of chances.
You can always try making them on purpose and hoping we don't catch them.
Slip one in.
Yeah, good luck.
Well, I think at this point, with this class, we have proven the open source concept is right. The many eye philosophy, when you have the source code available, then people will actually check and see problems. Because so far, I have not been able to make a mistake without anyone noticing in the class. All right. So what we'll do is this time I will run the program again. I'm not going to recompile, but I will show you how I can change the test cases without having to change the source code, because I have a breakpoint here, which is call here. Okay, so let's go ahead and run the program again, but this time we put a breakpoint at call here, and run the program. Now it has stopped at call here, which means I have already reserved the 8 bytes on the stack before the call instruction. In fact, I can double check that that is the case. I can do an x/2wx, which means I am displaying 2 32-bit numbers on the stack in hexadecimal, and I want to start displaying at exactly where the stack point is pointing at, and you can see that it has got both numbers pushed. This is my base, which is parameter b, and this is my x, this is my parameter x. If I want to change one of these things, I can do something along the line of, let's see, set memory region. No, that won't work. I think it has to be a set var. Okay, set var, evaluate expression and assign result to variable var. Var may be a debugger, convenience variable, and the actual variable expression is something like this. I want to see if I can do the indirect thing. Let's see. So set var, whatever ESP points to is going to get a value of, it's 89 right now, let's change it to 0. Attempt to reference a generic pointer. Okay, fine. It is now not generic. Cast it, right? If it is generic to begin with, make sure that now it is not generic. Okay, now just because GDB does not complain, it does not mean that the right location is initialized to 0. So what we need to do is to confirm that it is parameter x that is now changed to 0. So this just confirms it. Okay, we just confirmed that we are printing 0 in base 9. Now 0 is 0 regardless of the base, and this is also a good test case because it does not do any recursion anymore, and we want to make sure that it does print a 0 in this case. And
It's already running at call here.
oh, so I have to continue instead of run, and it does print a 0, so it does work correctly. Yep.
So if you want to increment to the second one, you just put in your set bar just plus 4.
I think so. Let me see if that's the case. So, and in this case, it is you do need a Well, okay, there are two ways to do it. If you don't do the parentheses here, then you have to say a +1. Okay, but you don't want to print something in base 0. You want to print something in base 2 or 3, because base 0 means we're going to have a division by 0. So let's say this time we want to print something in base 2, and also we change the number that we want to print to. Okay, let's use one base 2 number that we already know. Let's say 255, which is 8 ones. Okay, and then we continue the execution, and it's printing exactly 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. So the base conversion is working. And that's exactly what my script is going to do, is it will put a breakpoint, and it will change the memory location in the stack, and then it will continue execution into the subroutine, capture the output of the program, and then check whether the output of the program is matching what it is supposed to be. Any questions about this homework assignment? Were there any significant difficulties with this homework assignment? What was it? Go ahead.
Just not realizing I had to initialize EDX.
Ah.
You get strange answers if you don't.
Yes, because in that case the most significant 32-bit of a 64-bit quotient is just some bit pattern, some leftover stuff from whatever calculation you did before. Yep.
Not being able to use direct based indexed memory addressing. Not being able to put a $sign before your label in your register.
So you want to get the address, but use the base addressing mode.
Yeah.
Aha. But you should be able to do all the calculations. I mean, it's just a
Yeah,
matter of
just the
spelling it out.
calculations, But it seems like you should be able to do that if you can do anything else.
And yes, you can. I just have not talked about that instruction.
Would you mind discussing that instruction, please?
It's called LEA. It's load effective address. Okay. Next. Any other major concerns or major difficulties that you guys encountered with this program? How many people have the program do a segmentation fault, and then the address of the instruction that is in trouble is like 8 or 0 or something like that?
It was 9
Okay.
for the longest time because that was the base.
Yep, and that means your stack pointer is not balanced. It is using the wrong part of the stack as a return address. Okay. Any other strange things that you guys observed when you try to write or debug this program? Nothing.
My computer actually turned into a portal that traveled through time, and it was weird. I had to restart.
I thought we told you not to divide by 0.
Okay. Any other questions about this program? It's okay? No problem?
Hey.
All right. Okay, if there are no problems with this one, then we'll go back to our current content or current topic. We are already done with returning a scalar. Okay, so the next topic that we have to talk about is how do we do all those other fancy stuff that we can do in C. In other words, we are now moving on to topic 10. Topic 10, the first part of topic 10 talks about data structures, and I can't remember which one is older. I think this is the old version, and this is the new version. Let me double check. Yep, this is the old version, which is still valid. Okay, it's still valid. It's just presented in a way that I later on saw a better way to present it, and that's why we have this slide instead. But they're both good. I would read at least one of these two. Okay, if not both, at least one would be good. All right. So we are now talking about structures. Okay. Has everybody encountered or have you guys all learned what is a struct in C? Yes? Okay. And for those who come from a Java background, it is the same or similar to what a class is. Okay. So here we have a struct definition. I'm just highlighting the definition here. What exactly is uppercase X? It's the name of the struct. Okay, it is not an object of this type. It is the name of the structure. which is similar to the name of a class. In fact, a struct is really a class. What is special about a struct?
Doesn't a struct start public?
All members are public. Yep, by default. Yep.
Can you make the font a little bigger?
Sorry?
Can you make the font a little bigger?
Bigger font. Yes, I can. Yep.
By convention, structs do not have member functions.
They can have if you use
By
a C++
convention.
compiler.
They're not
By
supposed
convention,
to.
yes. By programming or by programmer convention, yes.
Yes.
Yeah, but in terms of the programming language, C++ does allow you to put member
They
functions
technically
into a
can,
struct.
but it's considered bad practice.
I don't use C++, so no comments there. I just do C99. That's the only thing I use. All right. Okay, so in this case, C is the name of the structure. To make a variable out of the structure, then we have to say struct x object1, and now we create a variable called obj1 object1 that is of the type of struct x. Now this part is different from C++, because if you define a class name x, you just have to say x and then object1, and that will create a variable object1. But in C, you actually have to mention the word struct before you can use the name of the structure to manufacture anything. But since I'm just using plain C and not using C++, this is the syntax that works.
It's because you didn't type def it. It's because you didn't type def it.
You can type def it, but why do that? There's no need to do it. All right. So the question now is, where is each member? In other words, if you look at obj1, it is going to take up some number of bytes in memory. The question is, where are these individual components in memory when we create object1? So hit this slide here. In C, we access the individual members of a structure by name. So in our example, we can refer to the score member of C, which is also a member of obj1, because struct x has a member called C. I think it may be better if I display both pages at the same time, so this is what I'll do. There we go. That's good. Okay, so you can see that inside a struct x, we have a member called C, but the member C itself is not a scalar. It is also a structure, and within that structure, we have answer and score. So that's why I can refer to obj1.c.score, and that basically refers to this particular item of the variable object1. Do we have any questions about the syntax of the language? The dot notation, and then a member can also be a structure. No questions about that? That's all good? Okay. Now, in assembly programming, there's no native method to define structures, okay, which is a bother, because a lot of times we want to write some subroutines strictly in assembly and still be able to pass a structure defined in C code to the assembly code. Okay, so the assembly code can do some processing and then return back to the C code. So basically what we have to do in assembly is we cannot do something like this. This is high-level programming. In assembly, the only thing we can do to emulate the effect of this is to define symbols. We have to define symbols to define where is the beginning of a member compared to the beginning of an entire structure. So we can define the relative position of a member compared to the beginning of the entire structure. That's what we can do. The first generally accepted rule is that a member is listed before another. If a member is listed before another member, then it should have a lower address. In other words, in this case here, member I usually has a lower address than CH, and CH usually has a lower address than C, and within C, answer has a lower address than score, and so on. Well, but that is not always the case. Okay, it is not always the case. It's just in general that is the case, because the compiler can say, "Oh, I can reorder these things and pack it in a different way." Okay, the only thing the C compiler has to guarantee is member C has to be contiguous. In other words, I cannot split up answer and score and interleave it with the other stuff. So this portion here has to be contiguous, but everything else, it can reorder the address of all these members so that everything can pack really well to save memory space. But this is just the beginning of the fuzzy rules that apply to how members relate to other members in a struct, which means that is kind of difficult to deal with. So in our example, what we want to find out is, one of the things that we do want to find out is what is the difference between the address of this particular member versus the member of this particular member here. In other words, this is going to be a number, okay, because you are subtracting a char pointer from a char pointer, which will give you an integer. The integer tells you the differences between those two addresses. The question is, well, what is it going to be? Is it always going to be positive? Because it seems like it should be positive. C is defined later than CH. Well, even that cannot be guaranteed. So that means, we have to use, another approach. And the other approach is done here. We have to first find out what are the offsets of members within the structure. Okay, it's just that. How do we do that? Well, this is how I would do it. Okay, now this is really, I don't think it is obscure. It is just not very conventional programming, but nonetheless, it is not obscure. I'm writing a C program. Okay, this is a regular C program, plain C program, not C++. I use a whole bunch of printfs. Do you guys know what is a printf? Okay. So with a printf, what I do, okay, let me show you the entire offset macro first. This is the offset macro. The offset macro is nothing more than taking the address of M, which is the name of a member, take the address of that, and then cast that address into a char pointer. I want to cast everything to a char pointer. Why?
So you can do math.
So I can do math. So the math is done in byte, counts of bytes instead of counts of integers or counts of words or whatnot. So this way, I guarantee that I'll be using byte, counts, and I just subtract the address of the object itself from that portion. So this will give me the byte offset of member M from the beginning of the object itself. Is that okay so far? What the macro is doing? Okay. So the macro always gives me an integer. Okay. It should always give me a non-negative integer, because nothing should be lower than the address of the entire structure itself. Okay. So the program itself is really just tedious, because what I'm doing here is I'm saying, okay, let's see, what is the address, or what is the offset of member I from the beginning of the entire structure. The calculation is actually done by the macro, that is here, and the printf statement is just printing that to the screen to standard out. That's all it's doing, and I'm doing this to every single member inside the structure, and the last one is really just the size of. I just want to print the size of a struct X, so that I can know how many bytes I'm supposed to allocate when I need to reserve space for one struct X. Are we doing okay so far? Okay. These underscores are extra. These are actually bad, things, because when I convert it from the source code into here, it decides to replace all the spaces with underscores. So some of these underscores are real, and some underscores are just artifacts of the conversion. Yep.
So, do we have to rerun this every time we recompile the type def for our struct in
Yes.
case it decides to change its mind?
Yes. But I can make the make file automatically take care of that. Yeah. So, first thing first, okay, we want to see what this program actually does. So let's go ahead and write a program like this. So this is a combination of C and assembly, but at this point it's all C, okay, because we have a struct defined in C, and then we have the assembly code, a C program to print out the offsets. So let's go ahead and do this step here, just so that we know exactly what this program will do. First of all, I have x.h, which is the header file that will define the structure itself. So we'll have copy and paste. And I'll go ahead and change a little bit of that. Typically, this is what I usually do, is I will define a macro that is related to the name of the file itself. And I will say if this macro is not defined, then I'll go ahead and define the macro and do all the definitions here, and then put a pound and if at the very end. So this way I can include x.h multiple times without causing any problems. Yep.
What's that last end if do? You forgot to comment on it.
Hmm?
You forgot to put the comment on the last end if, so I don't know what it does.
Comment?
Yes, you always put a comment on your end ifs.
Oh, it's ending the if not def.
Yes, but you always put a comment on it so you know what it does. Thank you.
Is that what you're looking for?
Yes, very much. Thank you.
Okay. So this is just a header file. In your C class, you should have talked about what a header file is. Pound include is not magical. It is not even close to magical. In fact, it is very brute force and very literal. Because what it does when you see a pound include is it will literally go to the file that you're pound including and treat it as if it is a part of the file that you're compiling. That's basically all it does. There's nothing magical about pound include. Okay, so this is my x.h file. And now we're moving on to the C file. The C file is in my other browser, which is here. So I'll do a copy here and cat to, did I use a particular name? x_struct.c. Okay, so let's do that. x_struct.c. And then paste that code. And this time I definitely have to go in and actually do some, cleaning up, because some of the underscores, are actually spaces, or they should be spaces. So we'll go ahead and finish this up. First of all, I have to remember to pound include stdio, which is the system header file that I need before I can use printf. I can use printf without that, it's just better to do this so the compiler does not complain.
Should you also include your header file?
Sorry?
Should you also include your header
Yeah,
file?
that's already done here. That part is
I
done.
see, okay.
Yeah. Yes?
What is printf?
What is printf? Printf is a function to do formatted printing. Okay, so I just need to replace some of the underscores with spaces. Just tedious. There we go. We got everything done. And now we are ready to put the whole program together. I'm not going to make a makefile at this point. I'm just going to use GCC in a very shorthand way. So just -o x_struct x_struct.c. We have a lot of characters that are not printable because I copied and pasted from a web page. It might be better off if I just rewrite the whole thing from scratch.
Well, all you do is have to hit insert and just retype over everything you just did.
Yeah, I could do that.
Replace all your quotes.
Oh, it's the quotes. The quotes are the ones that are in trouble. Now, what was
Put in
the
slanty quotes instead of straight up and down quotes?
well? The quotes are not the only one, because it also identified a few other characters. So I think the quotes are not the only problem. So I'll just go ahead and just retype everything.
Now we get to really see how proficient you are at typing. Because all the errors.
And I think I'm missing some end of lines here, because otherwise everything is on the same line. That would not be good. A lot of the typing exercise programs, they prepare people for the real world, but it doesn't really help programmers. Because a lot of the keys that we use, most other people do not use at all.
That's something I've been meaning to ask you. Have you ever looked into Dvorak keyboards?
Nope, I'm too lazy to learn something new.
Supposed to be easy to learn.
Dvorak is so last decade. You should be learning Colmac if you're going to learn anything.
Uh-oh. I lost track of what it is supposed to be. Oh, there's something at the end of each line too. I think that's the line break character, which is also non-printable.
So run it through DOS to Unix and Unix to DOS a few times. Run it back and forth through DOS to Unix and Unix to DOS a few times.
Maybe almost done here. Yep, it's almost done. It's complaining about how include express file name on line 3 and line 7. So line 3, oh, okay, it's the quote again. And line 7. Oh, that's because the pound include was not successful, so the struct was not successfully defined, and so fixing one problem should fix both of those things. Yay!
Hey, one of those cascading errors you're always touting us about.
Okay, so this is all the program does. This program, which is kind of obscure, is just printing a bunch of numbers. Now, what does this look like to you? Does it look like something that belongs to an assembly source code? Yeah, these are all label definitions. They're all valid label definitions. So that means the output of this program can serve as an include file to an assembly source file, okay, which is the first step to make sure that your assembly source code is consistent with a C program when you use structures. Are we doing okay so far with the concept? This is a tool, okay? We use this tool so that we can figure out the exact displacement or offset of structure members so that we can do it in a way that we can take the output of this program and treat it as an include file from the perspective of an assembly source program. Yep.
Is it allocating a whole 4 bytes for a
Yes, it
char?
is. Yes, it is being extremely wasteful here. But you can change the compiler option so that it is not wasteful. I think that's a pragma too. So you can change that to use less space, so you can pack more stuff into less memory space. But the whole point is, if it does change that, these numbers will change accordingly. So my assembly code will be consistent with the C code when it comes to the understanding of the structure. Okay. So that part is done. So in this case, X is the name of the structure. Blah 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 blah. Okay, that part we are done already. So we are moving on, using a structure in assembly language code. Okay, so here's the fun part. How do we use it? Now, first of all, we have to make an x.inc file. Now, how do we make an x.inc file? The include file, to be included in the assembly source code. We can redirect the output of x_struct and capture that into x.inc. And then in an assembly file, we can then include it. Okay, so this is what I'll do. I'm just doing everything. This is a practical example of how to use all these tools and put them all together. Okay, I would not use a makefile to basically throw another thing into the whole mix, even though a makefile eventually will become extremely helpful. And instead of doing that, I'll just do everything by hand at this point. If I want to do it by hand, it's easy. Okay, we just have to run x_struct by itself. But instead of printing everything to standard out, I will capture the output of this program into a file that I call x.inc. I cannot use x.h because x.h is already used as the include file for the C program. So I don't want to reuse the same file name, So this time I use x.inc, and inc stands for include. Okay, are we doing okay so far? All right. Now let's go ahead and write a simple program to test whether this will work or not. Okay, so we'll just go ahead and write a program called x.s, and we'll say include x.inc. All right, and in the data section we'll say I want to declare an object. Let's say we're defining a global variable. In this case, it's not a part of a stack or a local variable, and we say object 1 is something that will require x underscore size many bytes. Are we doing okay so far? Yep.
How will it differentiate between pound include and a comment of include?
It does not. If you have include or if or else or and if after the pound, it is done. The preprocessor will process that. If it is anything else, it is comment. Yeah. So that part is kind of brutal. That's kind of bad. Okay. And we'll just finish up this program with the usual stuff. Move $1 to EAX, move $0 to EVX, and request to get out of this program. Because all I want to do is to make sure that I can actually use the symbol that we call x underscore size. You're pretty quick. Oh, not quick enough. Okay. All right. So we'll give this a try, okay, and see what happens using our usual way of doing things. This is our usual way of doing things. X.s, x.o, x.s, and it will say, well, I don't know what to do with it because pound include is actually not processed in this case. Okay? Because the assembler does not understand that there's such a thing called a preprocessor or a C preprocessor. Did you guys talk about the C preprocessor when you took cisp310? Okay, so that was a concept that was briefly described. I hope. Briefly is good. Okay, so in this case, the preprocessor has not been run, and so the pound include actually did not do anything. So what I need to do is I will have to change the file name. Okay, I'm changing the file name to from lowercase s to uppercase s. Now, Linux is case sensitive, so this actually is a different file name at this point. And then the second thing I do is instead of using AS for assembler, I use GCC. GCC-G, which means to include debug information, -C, which means to give me an object file, and then I give you the source code, which is x.uppercase s. This time, it doesn't have any problem. Okay? Because GCC, even though the name implies it is GNU C compiler, it can actually take a whole variety of input files, especially also not just a source file, but also other types of file. But in this case, in terms of the source file, the extension .uppercase s tells GCC that, oh, treat this one as an assembly source code file. But not only that, also make sure that it goes through the C preprocessor first. Are we doing okay so far with this? So we're changing the tools a little bit. Instead of using AS, which is the assembler, we are now using GCC so that you can go through the CPP or the preprocessor before everything is done by the assembler itself. The effect is about the same if you run CPP by hand. Okay, CPP is actually a program. Okay, if you want to see what it is, you can man it. Oh, no man page for CPP. But it's a preprocessor. Okay, CPP is a preprocessor, which means I can redirect x.uppercase s into CPP and see the output of it. This is the output of CPP. It's basically saying that this part here is included. Okay. The pound stuff is basically just saying where are we in the original code? That's basically what it is. Okay. All right. In the last 5 minutes, let's go ahead and make a file for this thing so that we understand the dependency between all these things. Because we have x.h, which is a header file in C that defines the actual structure. we have x underscore struct.c, which is a helper program. Its only job is to print out the displacement of each individual member of a struct x object so that we can take its own output as an include file to our assembly source code. We have our assembly source code, which is x.uppercase s, which means it has to go through a preprocessor before the object file is generated, before it's fed to the assembler. Okay, so let's go ahead and find out what are our dependency. The first thing is our executable. Let's just call our executable x. Our executable depends on just x.o itself. At least at this point, we don't have any other subroutines to link with. And to get this done, we can still use LD. LD will still work in this case. So LD, and we can specify LD-O, and I cannot remember I think add is the target, and caret is the dependency. Okay. So this will take care of the executable. The next thing is, well, how do we get x.o, which is the object file? Well, the object file depends on a few things. It depends on x.uppercase s, which is the source code, and it also depends on x.inc, which is the include file in assembly. Is that making any sense? Because we pound included x.inc, so if we change x.inc, the object file has to be reassembled or recompiled. Okay. And to get this done, we cannot use AS anymore. Now we have to use GCC. So GCC -G to include debug information, -C to generate the output, and in this case, we only have to indicate x.s, which is the first of the dependency. There's a way to refer to only the first of the dependency, but I can't remember how to do that. Okay, now we have x.inc. How do we generate, or what does x.inc depend on? It depends on two files, not just one, but two. It depends on x underscore struct.c, which is the C program. It also depends on x.h, which is the header file that defines the structure, right? Okay. And to get that done, we can do GCC. Okay, I take it back. We have to take it one step at a time. Take it one step at a time. Okay, x.inc depends only on the executable x underscore struct. And to generate x.inc from x underscore struct, we just have to run x underscore struct and then redirect its output to x.inc. Is that making any sense? You can put any command you want, as long as the command gets what you need to do done. I mean, that's good. So the last part here is, how do we get x underscore struct as an executable? That depends on x underscore struct.c, which is the source code. It also depends on x.h, which is the header file that defines the structure to begin with. The command to generate the output in this case is GCC again. We want to specify the output as x underscore struct, and the source code is just x underscore struct.c. So this makefile defines the dependency of all the components in this big mess. And the objective is quite simple. The objective is, if I change the structure itself, I want an easy way to make sure that my assembly code also knows how to deal with that. Okay? But this is not going to work if I add a new member to the structure.
Yes.
It is going to work. As long as the assembly code does not refer to the new member, no problem. There's no problem whatsoever. Okay?
Well, yeah, if you add a member, then of course it wouldn't have it.
Well, then I just have to change x underscore struct.c to also include a line to print that out. Then I'm good to go again. Okay, so let's see if this works or not. Okay, this is my makefile. I can take a look at my current.
Run make clean first.
Yeah, well, I don't have anything to clean. There's no clean target predefined. So I'm just going to clean it up by hand. Okay, these files are all generated. x.o object, which is an object file, that's definitely generated. X underscore struct, which is an executable, is also generated by the compiler. X.inc, the include file, is also generated. It's generated by the executable that we call X underscore struct. So I can remove all these files, and if I say make, it will automatically pick the first target, which is the executable X, as the main target, and it will figure out the dependency and go through all the commands that are necessary to make this happen. Let's see if that works. Yeah, it complains about the linker because I forgot to do something, right? I forgot to do a dot global underscore start underscore start. Okay, now we should not complain. No complaints now. Okay, but this is not illustrating the full potential of this make script here, because what I want to do is to do something like this. I want to make a change to the structure. And what I want to do to change the structure is I'll just define some kind of buffer that takes up 256 bytes here. And between these two things, I want to define something else that would take up a lot of bytes. Well, maybe int, lots of ints.
12.
Terrific names, 4,096. Okay, so I'm completely messing up the displacement of these members from the beginning of the structure, right? But as long as my assembly code does not refer to lots of ints or buffer, they should be okay. It's just now that our focus is this going to trigger, if I say make again, is this going to trigger all the commands that are necessary in the right order in order to bring X as an executable up to date? That is the big question.
Yeah.
Well, I'm hoping that it does. And it does. Now you can actually see all the commands that we went through. The first thing is we want to regenerate X underscore struct as an executable. Okay? But once we have the new executable, we have to regenerate the include file from the assembly perspective. Once we have the new include file from the assembly source code perspective, we have to reassemble. And once we reassemble and get the object file, then we relink to the executable, and now everything is up to date. Okay, is that okay so far? So now we can see, how the make file is very, very useful. Now the make file at this point is still not very automagical. Yes, I said automagical. Because it can be a lot more magical. The part that is not automagical is this part here. Okay? I have to say explicitly that x.o as an object file depends on the include file that is called x.inc. I also have to say explicitly here that the executable generated from the C code has a dependency on x.h. If I forget, then it will still work, quote unquote work, until I make changes to x.h, then everything will fall apart. Okay? So there are ways to fix these two, but I'm running out of time today, so I cannot show you how to even automate this part, is to figure out the dependency on header files of the source code. The slide that I showed a few weeks ago when we talked about the make file, that actually shows you how to do this, so we can actually just copy and paste some code and make it work. All right. So there are no new outstanding homework assignments. We are done with homework assignment for the time being.
Why did we even come to class?
Well, I'm just stocking up all the new concepts. So the next homework assignment is going to be.
That's not good. Right during the break, huh?
Stockpiling. Yeah.